When you build a home lab, it might start off simple, and then you're 5 hours in, you're doing ZFS, SMB, NFS, a couple of containers, maybe a VM or two, and suddenly networking is the thing that decides whether the whole home lab is rock solid or a complete dumpster fire. Today, we're going to use the Houston UI to explain bonds, teams, bridges, VLANs, VPN configurations, and I'm going to explain what each one actually does, and more importantly, how it fits into your home lab and when you'd use each one in a storage NAS, virtualization, multiple other things. Howdy folks. Zach Perry back here with 45 Home Lab. In this one, we're basically building a mental model for Linux networking blocks in Houston, using that as our jump off point. And once we get those blocks in place, everything kind of becomes Lego. Until then, it's just kind of a pain. Or at least it is for myself with these kind of abstract concepts like networking when you get past the physical layer. But let's go in and talk about VPNs, bonds, so multiple NICs pretending to be one, teams, which look like bonds, but kind of a different tech, which we'll get into, bridges, so the software switch VMs plug into, VLANs, how you split one wire into multiple networks, and under the hood, we're using Network Manager and Firewall D. Not that that'll have a huge impact on what we're doing today. There are other options available, but this is what I'm used to, and it's what our Houston UI uses. Now, for today, we're gonna be utilizing the HL15 2.0. With an ASRock ROMED8-2T motherboard, already has an LSI 9400 HBA in it, a 4060 low profile. I also threw in 3 10 gig NICs, and that is accompanying our already onboard 10 gig NICs on the motherboard. And we still have an X16 slot left over for any of your other needs that you might have. So a lot of stuff that you can squeeze into a very small, very solid package. All right, so first thing we're gonna jump off here is adding a VPN. So here's what we're gonna do. We have our networking module within the Houston UI here, again, built on the Cockpit project. And we can see our first two interfaces here are ENO1 and ENO2. Those are our onboard 10 gigs. Then we have one of our NICs here, our second NIC here, and each one of these NICs is 2 interfaces, 10 gig. Not that we have it connected to a 10 gig uplink switch, anything like that right now. So we will see 1 gig throughout. And then here is our third one right here. Now, first thing we're gonna do is add a VPN. Now there is quite a bit to this when you actually look at it here. First time setting up a WireGuard VPN. First thing we're gonna do here is when you think of a WireGuard VPN or any, to be honest, you're gonna make an encrypted tunnel interface on Linux and then route your traffic through it. Now, first things first, we are going to name this, stick with the default WG0. And this is literally just the Linux interface name, same as ETH0, Bond0, BR0, it's just a network device. So this is the default first tunnel name. And if you run multiple, you can call them whatever you want. Now, rule of thumb is 1 tunnel for 1 interface name. Now, your private key or your generated key here that we can see, this is the identity of this machine in WireGuard. Now, it has no username, no password, just keys. It's generated, always on the move, it's the safest. So then you have your other option here, paste existing key. So if only if you're restoring a config that you've had previously and you want to use the same identity, as always, keep this thing secret. If you see private secret anywheres, I'm sure I don't have to tell you, but keep it close to your chest. So that's because if somebody gets that key, they basically have the key to the front door, the back door, wherever. But let's look at the public key next. So let's go back to generated here. And that's the shareable half of those keys. So this is the part that you copy to the other side, the other client. And the mental model to kind of keep in mind for this is your public key is how others talk securely to me. And if the other peer doesn't have that public key, you can scream into the void forever, nothing's gonna happen, and nothing connects. Now, we have here our listen ports. So 0 is the default here, but we're not gonna leave it as default here. So this means that Network Manager would just pick an interface. Now, let's do a common default here. It doesn't have to be this, but we'll do 51820. So this is our listen port here, if I didn't mention that already. And this is the UDP port WireGuard listens on. Now, quick rule for this is if this box is the server hub, pick a fixed port like 51820. If this box is just client, auto's fine for the most part. And if you set a fixed port, the firewall needs to be UDP. So that's probably one of the few times I'm going to reference the firewall within this, but just to make note of it. Now your IPv4 address, this is assigned to the WireGuard interface itself. So let's say we're gonna set here to something like 10.20.0. Let's say 2/24. And then our client is, let's say, 10.20.3/24. And so every WireGuard interface, it's gonna need an IP. And you're gonna pick a subnet that doesn't overlap in your homelab LAN. So this wouldn't do for me right now because I'm on a /24. So let's say if we made this a /25, something or other. But when it comes to peers, we would go to add peer here. And WireGuard tunnels, they're simple until you hit the whole peer section here, which I will be upfront, a lot of things within Houston, I didn't even really use myself, WireGuard VPN being one of them. So some of these I am coming at as a bit of a layman, so it is kind of educational for myself as well as anybody watching this here. So each peer is going to be one remote device I trust and that I can route to. So having that direct peer-to-peer connection, that peer public key, that's the other device's public key that is going to be required, and that peer endpoint. So you're going to do a host and a port, and this is where do I send packets to reach them. So let's say you have a laptop going to your server here. That endpoint is required, so the server has a stable address, or if you're doing server to laptop, the endpoint is optional. Laptops roam around NAT, and if NAT firewall blocks it, then handshake never happens. Peer to loud IPs, this is critical, so if you have your public key here, you would have your endpoint, so that would just be that IP port that I mentioned, and this is kind of a big one here that I've seen quite a bit of. So this is not an ACL, this is routing essentially itself. Allowed IP means that if the traffic is destined for these specific networks, then send it to this specific peer. So if you have 10.10.10.2/32, let's say, just that peer's VPN IP, and then 192.168.50.0/24, that's the remote LAN, and 0000/0, that's full tunnel, everything goes through the VPN. So the allowed IP is what lives on the other side of this peer. Now, quick examples. So if we want to remote access, let's say my laptop here to this server, if it was in a different geographical location, different LAN. So the server here is going to allow my 10.10.10.2/32, and the client allows 10.10.10.0/24. Now, if you were doing full tunnel privacy VPN, the client allows 000/0, and the server does your NAT. Now, the Houston /network manager will handle stuff like keep alive, MTU, unless you override it. Now, let's go into something that I have used quite extensively, and that'd be bonds within Houston here. So, and the reason we didn't cover VPNs too much in depth here, just the basic stuff, is I find a lot of people will just do tail scale, open scale, things like that to get up and running a lot quicker, but wanted to cover it regardless. Now, when we come to bonds, so bonding is combining multiple physical NICs into one logical interface. And you do this for two reasons. So big one is redundancy, so you have that failover, so you don't have that single point of failure, and you have more total throughput. Of course, that depends on the mode that you select and if your switch supports that mode. Now, let's take a look at bonding here because there is quite a bit here. Now, let's say we want to take our first two 10 gigs here. We would select those, pretty easy. And you can do 4-way bonds, 5, whatever. You can select all these if you wanted, but we're going to keep it pretty simple, bare bones here, and just do 2. Now, our MAC address, depending on, we can just leave that as is. It'll auto-select. You can select it if you want. Now, we're going to name it bond 0, keep the default here, and work our way up as we add more bonds in the future. Now, the first bond here, that is going to be the kind of the rule of thumb that we want to keep for these is that you want to have NICs that are, or interfaces that are the same speed, the same type. So don't mix a 1 gig and a 10 gig unless you enjoy a little bit of chaos in your home lab. and prefer the same NIC model, so you're not running into any weird driver firmware issues, stability, things like that. Now, because we do have so many NICs in this system, we can select the 2 NICs here. Now, if you do have multiple NICs like this, you can span across them there. So if the entire NIC dies, you're still not dead in the water. You still have that redundancy there, but that's a little bit more of an advanced networking concept there. Now, Mac, we'll leave that default, and the mode here. So this is where you have a lot of decisions when it comes to bonding. So you can see here we have round robin, active backup, and we'll go through each one of these as we go through. But first one we'll cover here is what a lot of people use, especially in a home lab environment, is active backup. So you're gonna have one link active and the others are on standby. You have automatic failover if the link ever goes down. Works with any switch, no throughput increase like you would with LACP, but it is extremely reliable. And you're gonna use this for management networks, control planes, anywhere don't go down matters more than speed. Now, you're going to next look at LACP or 802.3AD, and this is your true link aggregation. This is where you're gonna get that additional throughput and bandwidth. Now, when I talk about getting that additional, it's like the way it was always explained to me when I first started was that you have your single interface, that's like having one road, one lane down the highway. Now, let's say there's a little bit of added traffic, rush hour, and everything's backed up. So by adding that second lane, you're not getting double the speed, you're getting double the amount of traffic that can go down the road. So you're increasing the width, not the speed, essentially. Now, what this is going to do is that you're gonna have multiple links that can act across, can be used across different flows, scales well with many clients or VMs, and you're gonna use it for things like VM hosts, storage client networks, NAS, Ceph public networks, if you do have a cluster home lab or a Proxmox home lab. This is very switch dependent. Your switch does have to be able to have the support for it there, so an unmanaged switch and even a lot of lower end managed switches aren't going to be able to do LACP. Going into round robin now. So round robin sends packets alternatively across all the links that you have selected. It can cause packet reordering and often degrades TCP performance. It's rarely recommended today. I do see it used a little bit depending on the use case. And as we go through here, these are going to be some bonding modes that are not really utilized, but I felt they still needed place. But it's going to be used if you have full control of your network and you understand the risks of it. XOR or balance XOR, it's going to select a link per flow using a hash that is MAC, IP, or port. Each flow uses one NIC consistently, and it requires a compatible switch configuration that allows for static config. And you're going to use for multiple clients, environments without LACP, but with static link aggregation. Broadcast, it's going to send every packet on every NIC. Maximum redundancy, maximum overhead. You're going to use it for very specific high availability HA or heartbeat networks. TLB or transmit load balancing. Balances that outgoing traffic only, incoming traffic still uses a single NIC. No switch configuration required. And ALB, so builds on TLB, uses adaptive load balancing manipulation to spread and receive traffic. And no switch configuration is required on this. It can really confuse some switches depending on the make, model, and its options available to it. So the rule of thumb is, or not solid rule of thumb, but what I like to say is if you can use LACP, use LACP. If not, go to active backup. It's simple, it's reliable. Everything else is only if you know you need that specific mode, you go ahead and use it. Now, link monitoring, let's actually take a look at that here. So MII or me will be the recommended. We also have ARP. So it's checking the physical link state itself. It's fast, simple, and the recommended default. Now you also have ARP checks. So checks reachability beyond the link itself, and it can detect upstream failures. It is a bit more complex. I've personally never set it up, but it is an option if it is something you want to deploy. And so solid default when you're doing bonding here would be active backup, MII monitoring, and 100 millisecond monitoring interval here. So you can set these intervals. The defaults are the defaults for a reason, because they're going to do for the mass majority of use cases. Now, next, a little bit different than bonding is going to be teaming. So Let's go to add team here. As you can see, it looks pretty much the exact same. So let's take another NIC here. So we'll take our 193, we'll select those. So teams look like bonding because it is link aggregation at the end of the day, but it's implemented very differently under the hood. Now think of it this way. So bonding that we just covered is kernel based, it's old, it is extremely proven. Just because it's old doesn't mean that it's not good. Team is more user space driven, more modular, more flexible on paper. Now in practice, that difference matters less than you'd expect. So what a team actually is, it's introduced to replace bonding with a more modern architecture. Now the logic is handled mostly in user space, not kernel space. The kernel module is a lot thinner. The behavior controlled by runners instead of bond modes. The configuration is JSON based, and it's designed to be easier to extend and script. Now that sounds great, but most environments never really need that advantage, at least not what I've seen here. I might be wrong on this. I'd love to hear in the comments below if you do use teaming regularly and what you use it for. But bonding is, like I said, it's older, it's simpler, and it's extremely well tested. Every admin understands bonding. Every distro installer and recovery guide assumes they're using bonding. Most switch documentations references bonding, LACP, not teaming for the most part. Teams exist, but unless you know that you need it, you probably don't. So what it actually does on paper, plain and simple, it's going to use multiple link watch mechanisms at once, react faster to certain link state changes, be dramatically controlled via team CTL or team DCTL, I should say, offer more granular behavior tuning. These features matter in a very specific environment. Now, usually automation heavy or vendor integrated setups. And that's what it does pretty well on paper, but what it does worse is that there's more moving parts. So you have Team D, you have JSON configs, harder to troubleshoot from memory, unless it is something that you've kind of been moved into, less community knowledge, fewer real world examples from at least what I could find online, less predictable behavior during failures. So when something goes wrong at 2 a.m., it's a lot simpler to fix a bond than a team. Now, when you have a homelab, again, like our HL15 2.0, you're going to use a bond, or I'd recommend using a bond, not a team, unless you already have a reason that you're committed to. So if you're matching an existing production standard, if your platform or tool explicitly requires it, you're already operate a team somewhere else and you understand it very well, if none of those apply, then bond is probably good to stick with. Now, let's take a look at bridges. All right, so now we're on to bridges. So this is a software link inside of Linux itself. This is the thing that VMs plug into, and they sit on the same network as your LAN, kind of like Proxmox's VMBR0. You can see over in the side here that we do have our virtual machines module, so you can set up some lightweight VMs right inside of Houston. This is where this would kind of fit in well. Now, we're gonna keep the name as just Bridge 0. Keep it nice and simple. You could call it BR0, anything like that. Now, the ports, so this is what the bridge actually connects to. With that, the ports are what the bridge connects. The common patterns is the bridge with a single NIC uplink, bridge sitting on top of a bond, so super common in servers themselves. So let's go on to our NICs down here. Or actually, we didn't use both of our 10 gigs on board, so let's use one of those here. So a little bit of a warning on bridges themselves. If the physical NIC currently has your server IP and you bridge it, you usually need to move that IP onto the bridge or you'll temporarily lose access. Now, talking about STP here, as you can see, we have options, should be called option because we only have the one, but if we go in here, click on that. So that is spanning tree protocol. It prevents a layer 2 loop, which can cause broadcast storms and take a network down pretty quickly there. For a simple VM bridge with a single uplink, STP is often disabled to avoid unnecessary delays. And if there is a chance of multiple uplinks, nested bridges, or lab experiments enabling STP is the safer choice. Now, the bond and bridge pattern here, so we would use, let's say, bond 0 for redundancy. So if we had created our bond 0 over here, let's actually go quickly here and create our bridge because our bond, because we are going to need that for our next section, which is bridging. Now, we're going to do active backup. We're going to select our primary. So that will be our active with 0F1. acting as our backup here in case F0 ever goes down. We'll add that real quick, and we have a bond super quickly there. If it is DHCP, it will add that IP automatically there. So configure IP, yes, IPv4, automatic. So should see that pick up there. And if not, we can assign it manually, but we'll leave that as is for now. And then we'll go over to bridges. So again, pretty simple, similar to what we've seen with bonding here. We're going to select our interfaces. So we never used our ENO2NP1, which is our other onboard 10 gig. And we'll just select one for now. Or actually, what am I saying? We're going to select our bond. That's the whole reason that we created that bond in the first place. So one thing that I'll cover just briefly here are options, or option in this case, STP or spanning tree protocol. So this prevents layer 2 loop, which can cause broadcast storms and take a network down fast. For simple VM bridge with a single uplink, STP is often disabled to avoid those unnecessary delays. And if there is a chance of multiple uplinks, nested bridges, or lab experimentation, enabling STP is the safer choice. So let's talk about the bond bridge pattern. So we're going to use bond 0, that's for redundancy, and then bridge 0 uses bond 0 as its port, and the host IP goes to bridge 0. So that's the kind of the server grade setup here. Now, this is, and I'll say this now because I'm sure it's going to come up a lot in the video that I'm kind of staring off to the side a little bit here. This is probably the video that I've done the most talking in because networking is such just a vast concept, even with these few options that we have here. So being that I have the memory of a goldfish, I do have a lot of my notes on my laptop here, so I don't go off on one of my many side tangents. So bear with me on that.
Are you sure about that?
But with that said, that's our bridges very easily here. So if I wanted to go over into our virtual machines, now I don't believe I actually have any set up, but if I wanted to add one and create virtuals, so select our system, give it a unique name, let's say BR0, and board mode, we can leave as net, and IP configuration, device, so we could do bridge 0 here, create, and then we would just activate it. But back into our actual networking tab here. One of the last things that we're going to cover is something that comes up quite a bit in any home lab sort of situation or setup, are VLANs. So let's bring that up here. And you see there's not too much to it, as we can see, but this is kind of one of those iceberg sort of things where it's like, oh yeah, Houston UI or any VM setups, there's not a lot to add here. But then when you actually go to where you have to set up the VLANs, make sure everything can communicate, especially if you have any sort of, if you have multiple VLANs, it can get a little squirrely. What VLANs are, for anybody who doesn't know, they're multiple logical networks over the same physical wire. Now you're gonna have a parent interface. So let's say if we wanna use one of our NICs here that hasn't been utilized yet. So let's take ENP193, and then we could also take our bond, create a VLAN out of that, or the bridge itself, but we'll keep it simple here and just use a single interface. Now, if you expect multiple VLANs, your switch port does need to be a trunk, but that's out of the scope of this. So our VLAN ID can start as 1 here, but I like to, and pretty commonplace to do things like 10 or 100, or kind of just, I wouldn't say best practice, normal practice, I guess, but you can set explicit VLANs like this here, and you can see it automatically sets the name to the interface and then dot whatever that VLAN ID is. Now, that naming convention this is kind of what you're gonna see in a home lab setup, in enterprise, but this is the kind of the key combo practice here. So if you have your interface, let's say we wanna create one here, and then we want to actually add another VLAN. So we can select our same one here. We'll do our P3 and then 20. And we have, let's say we have one for IoT devices that we don't want it talking to our internal network for Samba shares or any other things that we might have in our infrastructure that we don't want talking to each other. We don't want our Aunt Susan comes over and she wants to connect to your Wi-Fi. Well,
come on, Susan.
You don't want her taking up all your bandwidth.
Jesus Christ, Susan.
I don't know where I'm going with this, but at the end of the day here, it's a way to section off certain parts of your network using one logical link. Think of VLANs, and just to be crystal clear on them there, they're not going to route between networks. I mean, you can set it up in a way where they can, but again, out of the scope. They do not firewall anything, and they're only to separate broadcast domains. So Aunt Susan get her own separate broadcast domain. Now, routing between VLANs, it does need that router, firewall, host routing, all kinds of stuff there. Again, out of the scope of this. But yeah, with that said, all right, so that was a very high level of networking there using the Houston UI as our jump off point. So if you remember nothing else from this video, remember this. So VPN is a secure access and routing point. Bonds and teams, multiple NICs become one. A bridge is a software switch for VMs, and a VLAN is splitting one link into multiple networks for different things in your LAN. If you want to see everything that we have on offer, head on over to store.45homelab.com. All of our socials and the projects that we discussed are going to be in the comments down below. And if you want to see more deep dives like this, Proxmox, ZFS, networking, self-hosted tools, hit that like, subscribe, and I'll see y'all in the next one. Bye. Head on over to store.45. Head on over to, if you want to see everything we have on offer, head on over to, scroll there a tiny bit for me. Of course, when I come back to it, it's the one that has like the longest screen recording on too.